Hi guys, Mike here with a quick demo of post-processing in Unreal Engine 4. And what I'm going to make for you is this effect I'm looking at here where I have raindrops kind of sliding down the lens of my camera. And I would have spoken by now about the theory of post-processing and kind of what it is, why we need it, so I'll skip all that for now. And we'll dive in and actually make something in Unreal. So I'm actually going to remove what we're looking at right now. So it's gone. We're going to make that from scratch. So I'm going to dive into my content browser, into my materials folder, and a post-process effect is just a material. So nothing new there. Brand new material, please. I'm going to invent my own prefix here. I'm going to do PP for post-process, and that just allows me to easily filter when I'm trying to select an asset from a list inside Unreal. Raindrops, no thanks. I'd like raindrops. And I disagree, Unreal. I disagree because the other one is called test on the end. But okay, let's just put a 2 on the end. No, we'll get around that for now. I have already done this. I was testing before I was recording the video. So there is our new material, and let's open that up and start constructing this effect. So first thing I need to do when I'm making a post-process material is I have to kind of tell Unreal that, you know what, this isn't a normal material. Okay, we're going to use this one a little bit differently. So what we have to set is the material domain. So we need to click over here and we need to say post-process. And kind of tells Unreal our intentions with this material, and it also grays out all of these material inputs that don't actually work with a post-processing material. The only one we're allowed to connect our output into is emissive color. Okay. Now, what could I do here? Could I maybe, I don't know, chuck in a constant color, holding down 3 on the keyboard and clicking? And what if I connect that up? And let's pick a color really quickly here. We'll go with a light blue. I'm going to apply that. Now, what I want to do before I kind of go any deeper here is show you how to link up my processing material with a post-process volume. Okay, so right now I'm just in the minimal default scene in our starter content, which I believe comes with a post-process volume. If you don't have one, inside your modes window on the left here, you can do a good old search and you'll have a post-process volume. That we can drag out. But I have one here, and this actually comes full of built-in effects. So I can configure bloom, lens flares, depth of field, all those awesome things. But what I can also do is attach my own custom effects. And I can do that. I'm just going to scroll through this list. You'll see there's a section here that says post-process materials. That's basically an array of materials that I've created that will apply to this post-process volume. So I'm going to add one. Let's please add an element. What type? We want to link up an asset reference. We want to link up an asset in our content browser, which happens to be a material. And now I'm going to click my drop down. I'm glad I invented my little PP prefix. I would like raindrops 2. Okay, and well, okay, look at that. That's actually, the whole screen's gone blue. And that is exactly what our material is describing. We're saying, you know what, we're kind of iterating through the final rendered frame of the game. We're essentially applying a pixel shader to each final pixel in screen space. And in this case, we're just saying, you know what, make it blue. Discard all the work you've done. We don't care what the game actually looked like and what was really going on here. Just make every pixel blue. And Unreal, sure, it's doing what we've told it to do. So, you know, that kind of proves that everything's working and linked up. but you know, not great, not a useful effect. So let's get rid of that. And what I'm going to add now is a special node here that I'm just searching for with a right click. I'm looking for a node called Scene Texture. I'm going to add that in here. Now what this node allows me to do is read from any of the buffers that Unreal has already created for me. So those could include the diffuse color of every pixel on screen, the metallic, the shininess of every pixel on screen. I could get the world space normals as well. Or I could get the actual final image, including lighting calculations. So I can basically say with this node, hey, you know what, Unreal, just give me the final frame that you've created. And I can actually do that with this list over here. And these are all my options that I can actually link up here. And you know, what if I did world normal and I linked that up to emissive color, and I'm going to apply. Oh, okay, check it out. So now I'm actually reading the world normals from my final rendered image. Okay, so I'm just visualizing the normals of this scene, and yeah, kind of bluey's pointing up there, and that's all. Yeah, that's what we want to see. What else can I access? Just to look at another one of these. Roughness as well. That's probably a nice one to look at. If I jump back, you can see, yeah, this scene has quite a few varieties of roughness as well. So we can access all of that data. Maybe we would like some of that data for a particular effect. Things like depth of field, where we blur the distance of the image. Well, that effect's interested in the depth of our scene depth just there. Now what I want to grab is actually this one here, post-process input 0. I'm going to grab that one. And it's still linked up. I'm going to apply. And back in my scene view, it's like nothing's happened. This is what I already had. But my material, my post-processing effect, well, it's still there. It's still working, but it's just taking whatever we had rendered, doing nothing to it, and kind of just showing that again. So it's a pointless effect, but it's the first step to making something way cooler here. So, you know, what if I did something like, let's add a color to the screen. So I'm going to break that connection. I'm going to link it up in here. And I'm going to link up a color. I'm going to drag it in. Now I got a bit of an error here. So float 4 and float 3, how do we add those together? Okay, now what I might actually do. So this is a float 3 and color is coming out as a float 4. So I might mask my float 4 into a float 3. That will get around this quite quickly. So there we go. And adding black doesn't really do anything, so let's just add a very kind of subtle blue tint to the screen. So we're going to apply. Hey, and there we go. That's kind of working. Yeah, we're getting somewhere now. So we're taking the final rendered image and we are running a pixel shader on every pixel of it, and that shader happens to be adding a color to whatever input color we received. Cool, so all is well. Now let's kind of do something else here. Let's kind of build this up. I'm gonna go back to the shader that did nothing. Just whatever color we got as input, we give that as output. But you know what? What if I do something like, I have an input here for my UV coordinates, and I could do something like I could offset the UV coordinates that it uses. So what I might add here is a texture coordinate node. I'll put in a plus here and add. And for now I'm just going to add 0, so I'm not going to add anything. Okay, so if I just jump back and forth here, nothing's changed. Okay, so we're still using our input as the output, not doing anything with it. Now, what if I add in just a constant scalar. And I'm going to add 0.1. I'm going to apply. Okay, what's happened there? You can see my image actually moved a little bit. It's kind of shifted up a little bit and left a little bit, and you'll see the bottom and the right hand side are now kind of smeared and distorted. Okay, and the reason for that is, well, what we've done here is, if we think about our screen space and our UV coordinates, what we're doing with our post-processed materials, it's kind of like we have this full screen quad filling the entire shot. Okay, and what we see, our representation of the world, well, it's just a texture. Our input here, this red node, just gives us a texture, okay, of the rendered scene. And what we're doing here is just changing which part of that texture we actually sample to show on screen. So our UVs here, 0, 0 is the top left, 1, 1 is the bottom right in Direct 3D, which I'm using right now. So by adding 0.1 to both the U component and the V component, I'm kind of sliding the image the other way, left and up. Okay, so if I'm starting at the top left, instead of sampling the very top left pixel of my input texture, I'm actually moving across a little bit and moving down a little bit and sampling a different pixel, one of my neighbors. Okay, and when I get to the end of my texture, which we can kind of see with this line along here, well, we kind of run out of pixels to sample. We added 0.1, so we basically move 10% of the viewport to the right, and there's no pixel there. So what it actually ends up sampling is just the last pixel we had, hence we get this smeared, stretched effect here. Same along the bottom, we've run out of pixels to sample. So we just get the last row there. Cool. So, would I want to be doing something like that? Well, yeah, maybe. Not in this case, though. Not in this case. So, I think what I might do, I'm going to get rid of that. And what I want to think about is, we're trying to make these water drops. And when we have, water drops on a window or something, and you look at it, the world behind the water drop is kind of distorted, and that's what I want to kind of simulate here. So, to distort this image we're looking at, well, the technique is really no different to what we're doing here. We're going to add something to the UV coordinate that we're using to sample our input scene texture. Now, instead of constantly just adding the same thing to every pixel, what if I use a texture that contains some noise? So let me just filter out these channels. Here's just the red channel. So 0 to 1, 0 black, 1 white. And what if I, for instance, added the value contained inside each of these pixels to my UVs in my material? I'd still be offsetting the image, but I'd get this nice kind of distortion. So let's give that a shot. So if I hold down T and click, I get the texture that was selected in my content browser. And what if I say, you know what? Let's add the red, the value contained within the red color channel to our text coord. Oh, and we get this. So it's still kind of recognizably our scene. We can see kind of glimpses of orange and the sky. But it is probably way too distorted for what I'm trying to achieve here. And that's because this contains zeros up to ones, okay? Ones being white, zeros being black. And our texture space here, our UV space, is also 0 to 1 based. So this is actually just far too intense. Okay, if we were working through our scene texture and we wanted to sample the pixel where my cursor is, well, we end up adding that offset described in that texture, and that takes us somewhere, I don't know, maybe down here, nowhere near the original pixel we were trying to sample. Hence, we just get this mess of an image. Okay, so let's kind of calm that down a little bit. What I might do is let's introduce a multiply. So we're still going to take the value from the red channel. I'm still going to add it to our texture coordinate, but we're going to multiply it with a scalar here just to kind of calm things down. And I'm going to think ahead here and expose this as a parameter, which I can call distortion intensity. Yeah, that kind of does it. I think that'll work. And what if we say, what about, I don't know, 0.1 as the default value? So I'm taking the 0 to 1 value out of this image and I'm calming it down. I'm multiplying it by 0.1, making it 10% of what it was. And that, yeah, so you see that's really calmed down my distortion here. And that kind of looks like there's this steady stream of water just running down the lens of my camera for some reason, even though it's not raining in this scene. But that's kind of cool. That's really cool. So what else could I do with this? Could I maybe, what if I animate this noise texture so this distortion is moving even when I'm not moving? Because at the moment I only see the distortion as I pan around my scene. What if I add in a good old panner and I link it up with the UVs here and I set speed of Y to something like negative 0.1. Shall we give that a shot? I'm going to apply, I'm going to jump back, and oh, okay. So now it's scrolling my noise texture, and you can actually see it doesn't tile properly as well. I've got a harsh line along the screen there. That's something here it comes again. Okay, that's something I'd want to fix. I'd actually definitely want to fix that before I went further with this game. But I'm going to leave that for now just because it visualizes quite cleanly where this texture is actually repeating, and it just kind of proves, or helps illustrate that this is just an image scrolling up and down. We're using the values contained within it to offset those UV coordinates, so we end up sampling a different pixel to the one we're meant to be sampling. So that's pretty cool. So, you know what? I think the next step here is, what if I mask my distortion to some raindrops? What if I try and limit this distortion? Because I don't want the whole screen to be distorted. I only want the distortion to be where I have little raindrops on screen. So what I actually have inside my content browser here is a little mask called raindrops mask. Just a black and white image, kind of a picture of water drops on a sheet of glass. And what I'm going to say is, where this image is black, I would like no distortion whatsoever. Where it's white, I would like lots of distortion. And the in-betweens will kind of work themselves out. And what I like about this image is there are areas where there aren't drops, where it's still kind of a grey, like the water's smeared down the image, which is going to look kind of cool. We're going to see these little smears, not just the drops. So let's have a look here. What I'm going to add is a new texture, holding down T, clicking in my material editor. There's my water drop texture. Now I want to mask what I get back from these highlighted nodes here. Okay. So all I'm getting back here, I'm just getting a single number, a float. Okay, the red channel of this image multiplied by an intensity. Let's now multiply that by the red channel of this water drop texture. So what I'm also going to do is just a bit of a clean up here, move left, and that goes in there, like that. So I've only used the red channel because all 3 channels of this image contain the same data. So doesn't really matter which channel I use there. So let's apply that and jump back here. Okay, so you can see now I actually have some water drops on screen, and I also have some distortion behind them as well, especially around the table here. You can see where that's actually happening. Awesome, so far so good. Now, you know, one problem, I'm still scrolling that distortion noise texture. So kind of looking at this big drop here, the distortion's moving, which, you know, I probably don't want that to happen. I think what I'd actually like is the drops, the water drops, to actually scroll down the screen. Okay, I mean, you know, maybe I'd want this, like, maybe it's like there's wind, like blowing on these water drops, and they're kind of wobbling a bit, and hence we're getting that subtle distortion. But I don't want that for now. So what I'm going to do instead of panning this texture right here, I'm going to move my panner. So I'm going to break that connection, holding Alt, clicking to break it. What if I instead pan my water drops texture? I'm going to apply, I'm going to jump back, and hey, that's starting to look like rain. That's pretty cool. It's probably moving a little fast, but that's okay for now. So I'm panning my drops texture down the screen, and I'm using it as a mask where I sample some noise to distort the image behind the drops. Very cool. Now, at this point in time, I think I'd like to change something here. If we think about this noise texture, and if we just look at the red channel, so that's all we're sampling at the moment, we're adding the values here to our UV coordinates. These are 0 to 1 based. So that means, if we think about it, we're only ever allowed to sample a neighboring pixel that's either below or to the right of the pixel currently being shaded. And I don't really want that. Why can't what if I want to sample a pixel above where I am, or a pixel to the left of where I am? So what I want to do is I would like to remap the range I get back from this image from 0 to 1 to -1, 1. Okay, so that'll allow me to get a slightly more realistic effect here. So what I'm going to do is just make a bit of space here. I'm going to take my texture here. Now, to move something from 0 to 1 into -1 to 1, kind of visualize this on a little timeline. First thing I need to do is actually subtract 0.5, and that moves us into a range of -0.5 to 0.5. So we're kind of halfway there. So I'm just going to hard code in here. I'm not going to connect up a new node because I don't ever plan to expose it as a parameter, and this is a more compact way of representing that. So we've subtracted 0.5. So we're now -0.5 to 0.5. What if we multiply that by 2? That'll do it for us. That'll get us to in the range of -1 to 1. So I'm going to chuck in a multiply, and I'm going to multiply by 2. And I should also put a comment in here. I'm going to say remap noise from 0, 1 to -1, 1, just so I know what that maths is doing, because I don't have a very good maths brain, and I'll look back at this and be like, what the hell was I doing there? That looks kind of weird. Okay, so a subtle change, but slightly more accurate, because now really what's happened is, looking back at this image, if the color value in one of these pixels was between 0 and 0.5, well, we're going to sample left or above us, and if it was greater than 0.5, we're going to sample right or below us. Now, one other thing I want to do is, what if I use the green channel as well? What if I say that, you know what, the red channel, that can describe my horizontal offset. Do I sample to the left of me, or do I sample to the right of me? And what if we say my green channel, which contains some different noise, it's kind of offset. What if this channel controls whether I sample above me or below me? Right now we're just using one channel for both, which, you know, we've got extra data there. Let's actually use it. So what I think I'll do here is actually add in a component mask, which will allow me to quite easily just grab the red and the green channel. So I've actually grabbed all three channels here and then reduced it down to just the red and the green over here. Okay, and all our maths here still works because it's applying each of these to each element of my 2D vector, which is what UVs are. Okay. So another incredibly subtle change, but we're slowly getting closer to a more realistic effect here. Now that's pretty cool. I'm liking this so far. It's slowly growing on us. Now, you know, the last thing I think this needs, we're nearly done here. You'll notice that all the drops are moving at the same speed relative to each other. And, you know, that's not that realistic. Water drops don't do that. They don't kind of fall in a perfectly straight line either, and they certainly don't all fall at the same speed. So how could I do something like that? Because, you know, it may not be that easy, because I've got this texture. Where is it? Here it is. All my information regarding where drops are is kind of hard-coded into this texture here. So what I actually need to do is similar to what I'm already doing, actually. What if I distort this texture using noise like we did right at the start when I distorted our scene texture and it looked like we just had like a waterfall going over the lens of our camera? What if I do that to this texture here? It'll kind of look like a heat haze effect. And it means as I pan these down, the drops will start to kind of get a bit of a curve motion to them as well, which is going to look a lot better than just this linear straight dropping. So what I would like to do is let's just have a bit of a clean up here. Okay, I'm actually going to disconnect my panner. I'm going to put in an addition, a node here. Okay. Because what I want to do, I still want my panner, because that is responsible for animating this texture, sliding it. But in addition to that, I want to add in a little bit of variation to the output of the panner. So it's still doing its job, but whatever it gives back to me, I just want to add in a very subtle offset, essentially, and that'll kind of help me get that wavy motion. So what am I going to connect here? Well, you know, all of this up here is kind of what I want. I want to look up this noise texture and just add it to my UVs here to distort this texture. So I could reuse this. Okay, I could kind of drag this off to one side, grab its output, plug it in here, apply, and well, okay, you see what's happened here. So my water drops, it's kind of hard to see them now. They're actually really distorted. They're way too distorted that the effect is kind of losing its appeal. You can see we've really lost the shape of those drops. So let's make a little change here. Just like last time I used this, I multiplied its output with a little intensity just to calm it down. I'd like to do that again down here. And instead of just connecting it up from here and just using that intensity, I'm going to expose a new intensity here, because I'd like an artist to control these independently of each other. So I'm going to take my distortion and I'm going to multiply it with a scalar, which I'm going to expose as a parameter to my art team. And, you know, this one's kind of harder to name. This kind of controls kind of the pattern, or like the chaos, I guess, of these drops. So I might call it, I don't know, water drop. You know what? Drop, fall, or slide chaos. That's a tough one, actually. I might think of a better name and come back and change that, but that'll do for now. So if the chaos is 0, which it's defaulting to right now, well, we're just going to get the straight line effect we had before. If it is, let's perhaps chuck in a value here, maybe like a 0.5, and just have a look. Still a bit too strong. Okay, but you can see the visual effect that that's actually having. What about 0.05? Let's go quite weak here. And yeah, you know what? That's not bad. That's pretty close to what I'm going for here. You don't really want them waving around too much, but we really just want to break that linear straight line drop that we had going before. Now, looking at this, I think my panner is a little too fast, so I might halve the speed that my raindrops are actually falling down the screen. And that's looking a lot better. A nice calm effect there. Very cool. So, what have we got so far? That's what we have. And, you know, we're pretty much done here. What I might also do, just to finish up, is I think I'd also like to expose this to my art team. How fast the drops actually slide down the screen. And at the moment I've hard-coded that inside the settings of my panner. But I can actually connect that in from a separate node into the speed input here. So very easily I could chuck in a scalar, connect it up to speed, and I could convert it to a parameter and put in a default value. Problem is though that this is expecting a vector 2, as you can see in that description. And when I pass in just a single scalar, well, it's going to use that value in both the components of the vector 2. So my animation is actually going to go diagonal. It's moving across and up. Maybe there's wind blowing on my camera, I don't know, but let's kind of fix that. So I guess first question is, well, you know, why don't I put in a vector 2 and connect that up and expose that as a parameter? But the only two types of these constant parameters, apart from textures, among others, is scalars and vectors are kind of the main ones we're looking at here for numerical values. And the vectors are actually a 4-dimensional vector. You can see the little preview here has 4 numbers in it. And, you know, even though I'm only using the X and the Y component, not the Z and the W, kind of feels, I don't know, feels kind of dirty. I think it would be neater for my art team if they just saw a single float called drop speed. Okay, they don't have to worry about, you know, filling out zeros in the remaining 3 components. So let's make life a little easier for them. So I'm going to go back here, bring in a single scalar, make it a parameter, and this is my drop speed. Default value, I think we had about 0.05. You also notice in the panner it was negative to make it move down the screen. That's something I also don't want my artists to have to worry about. Okay, that they shouldn't care about that sort of detail. So let's expose this in a way that we convert whatever they type in to a negative number, and we then add it to a 2D vector, making the second component 0, so that we don't get any horizontal animation, removing the diagonal effect we just had. So what if I do something like, I'm going to add, in fact, I'm not going to add, I'm going to multiply with a 2D vector here, this parameter. I'm going to connect it up to speed. And what I'm going to set here, I'm going to multiply whatever the user types in by -1 and 0. Okay, so in doing so, I'm converting this single float here, this scalar, into a float2, into a 2D vector. Okay, the first component I'm negating because I'm multiplying by -1, and the second component I'm multiplying by 0, meaning it becomes 0, meaning we don't use the second component. So that, I think, is a lot neater, especially from an artist's point of view. And visually, that's not what we want. It's actually so it's actually going horizontal now, and I think I've got this back to front here. Yeah, so UV, the way I kind of remember it is the V is for vertical. So I actually want to remove the U component, the horizontal, and negate the vertical component. So just have that back to front there. And there we go. That's exactly what we're looking for. Awesome. Now this material, if I can find it, there it is. That's now finished. Okay, apart from some comments and some cleanup. I'm going to save that though. I'm done with that for now. Last thing I want to do before I finish up is I wanted to show you a workflow that is much easier to iterate changes. And we've already looked at material instances. There's no reason we can't make a material instance of a post-process material. Okay, so I'm actually going to do that now. I'm going to right-click my post-process material, and I'm going to call this PP raindrops 2 inst. Yeah, sure. Good on you, Unreal. That's a good enough name for me. And that's just going to open up my material instance editor here, the simplified version that I exposed to my art team. Here are my parameters: intensity, chaos, and speed. Now, inside my post-process volume, let's use the instance here instead of the parent. Okay, and now, if I just undock this tab, so this is my material instance, just going to put it off to one side. If I override these settings in my instance, I get real-time updates. So this is a better workflow than actually doing this in your main material editor on the parent material, because you have to keep hitting compile because it needs to, apply you need to hit, because it's actually compiling that into a shader, okay, into programming code. Our instances are not compiled, they're just a collection of settings that the parent uses. So this is really nice to get that real-time updating. I can revert back with a little arrow here to the default value. And let's just test all these. So my speed, we can really crank up. That's the chaos actually, so as I crank that up higher, yeah, it just turns into like little speckles. We get so distorted that we lose the ability to recognize the individual drops. And speed as well, if we just kind of speed that up a bit, well, yeah, a bit too strong there. So we're going to revert back as well. But a good practice to set up the material instance and link that up with our post-process volume. Let's save that and close it, just so it allows us to iterate changes with instant feedback, which is always a good thing. Okay, I think I'm going to end this video right there. thank you for watching. I hope this is useful for any of your future effects and even your assignment. See you guys later.